Hello. Our next topic is temperature coefficient of resistance. So since the ohmic change in resistance per degree constant, the fractional change in resistance per ohm will vary on the basis of the reference value. Temperature coefficient of resistance is the resistance change factor per degree Celsius of temperature change. This factor is represented by the Greek lowercase letter alpha. So from our formula a while ago, R2 over R1 equal to T plus T2 divided by the inferred absolute temperature T plus T1. We'll manipulate this equation, getting R2 equal to R1 multiplied by T plus T2 over T plus T1. So R1 multiplied by T over T plus T1 plus T2 over T plus T1. So agpadpada lang deta ken deto eh. So adding and subtracting T1 over T plus T1 ditoy. So we will get R2 equal to R1 multiplied by T over T plus T1 plus T1 over T plus T1 plus T2 over T plus T1 minus T1 over T plus T1. Parenthesis. So R2 is equal to R1 T plus T1 over T plus T1 plus T2 minus T1 divided by T plus T1. So this one, we will cancel or we will equate it to 1 kasi agpadamit ni numerator ken denominator na. So R1 multiplied by 1 plus 1 over T plus T1 multiplied by T2 minus T1. So this is now your temperature coefficient of resistance. So we will equate it in the Greek lowercase alpha. So this is alpha 1 over T plus T1. Simplifying your equation, we will now get R2 R1 multiplied by 1 plus alpha T2 minus T1. So this is now the formula of R2. regarding temperature coefficient of resistance. So this alpha here is the change in resistance per ohm. Fractional change in resistance per ohm. So T2 and T1 expressed in degrees Celsius. Again, T here, the toy T, is the inferred absolute zero temperature. Example number 1. Calculate the temperature coefficient of resistance of aluminum at 20 degrees Celsius. Using the values thus obtained, determine the resistance of an aluminum conductor at 62 degrees Celsius if its resistance at 2 degrees Celsius is 7.5 ohms. Solution. Given T1, our temperature 1 is equal to 2 degrees Celsius. T2 is 62 degrees Celsius. R1 is equal to 7.5 ohm. R2 is required. Also, temperature coefficient is also required. First, we will solve the temperature coefficient, alpha. It is equal to 1 all over T plus T1. 1 all over, so what is our T? Since this is aluminum in our table, T is equal to 236 degrees Celsius. 236 degrees plus 2 degrees. It is equal to 4.2 times 10 raised to negative 3 per degree Celsius. Solving for R2, our working formula is R1 multiplied by 1 plus alpha T2 minus T1. So R2 is equal to R1 7.5 multiplied by 1 plus 4.2 times 10 raised to negative 3 times T2 is 62 minus 2. Final answer, R2 is equal to 9.39 ohms. Okay. Example number 2. The resistance of a given electric device is 46 ohms at 25 degrees Celsius. If the temperature coefficient of resistance of the material is 0.00454 at 20 degrees Celsius, determine the temperature of the device when its resistance is 92 ohms. Given or solution. R1 will be equal to 46 ohms. T1 is 25 degrees Celsius. temperature coefficient of resistance, so that is alpha, at 20 degrees Celsius equal to 0.00454 per degree Celsius. And then R2 is equal to 92 ohm. Determine the temperature of the device when its resistance is 92 ohm. So that is T2. Saan tayo masolve ni T2? Makita ito ading nga our T1 ay our alpha is in 20 degrees. But in our formula, alpha is expressed in T1. So, ano ni T1? 25 degrees Celsius. So, kasano nga ron? Tipamayan tayo. First, we will get, this is 20 degrees. We will get the value of inferred absolute temperature at 25 degrees Celsius. Okay? So, given ni alpha 20 degrees, that is 0.00454 equal to 1 all over T. Alantay pa lang umuna ni T. Plus, our temperature here is equal to the temperature in your temperature coefficient of resistance. So that is 20 degrees Celsius. Solving for inferred absolute zero temperature T. So you will get 200.264 degrees Celsius. You are now ready to solve alpha at 25 degrees Celsius. Kasi dito iti kailangan tayo. At tay T1 tayo i-jacket naka 25 degrees Celsius. So, alpha is equal to 1 all over 200.264 plus 25 degrees Celsius. Our alpha at 25 degrees Celsius is equal to 4.439 times 10 raised to negative 3 per degrees Celsius. Okay, so na-solve tayo ni alpha 25. We are now ready to solve R2. General formula, R2 is equal to R1 multiplied by 1 plus alpha T2 minus T1. So, ni T2 ti unknown. Unknown. Substitute. Ano ni R2 tayo? R2 is equal to 92 equal to 46 multiplied by 1 plus 4.439 times 10 raised to negative 3 times T2 minus T1 is 25 degrees Celsius. 92 equals 46 times 1 plus, so distribute, so that is equal to 4.439 times 10 raised to negative 3 T2 minus 4.439 times 10 raised to negative 3 times negative 25, so that is 0.111. Stalatan. Okay? And then simplify. 92 equals, again, distribute. So 46 times equals 0.204 T2 plus 40.894. T2 now will become 92 minus 40.894 divided by 0.204. T2 is equal to 250.52 degrees Celsius. Okay. Example number 3. The resistance of a copper wire at 30 degrees Celsius is 50 ohms. If the temperature coefficient of copper at 0 degrees is 0.00427, what is the resistance at 100 degrees Celsius? Solution. We have initial resistance R1 equal to 50 ohms. At initial temperature equal to 30 degrees Celsius. If the temperature coefficient of copper alpha at 0 degrees is equal to 0.00427 per degree Celsius, what is the resistance at 100 degrees Celsius? So the unknown is R2, and we have a final temperature of 100 degrees Celsius. What will be the value of R2? So as you can see here, our alpha is in 0 degrees, but we need to get the alpha at 30 degrees Celsius. Our working equation is R2 equal to R1 multiplied by 1 plus alpha T2 minus T1. So what will be the value of alpha at 30 degrees? 30 degrees. First, we will solve. From our formula, alpha is equal to 1 all over T plus T1. So here we have a 0 degrees. The alpha is equal to 0.00427 equal to 1 all over T plus T1 is 0. So our T will be equal to 234.192 degrees Celsius. Solving for alpha 30 degrees equal to 1 over T plus T at 30 degrees. So alpha at 30 degrees equal to 1 all over 234.192 plus 30 degrees Celsius. Our alpha will be equal to 3.785 times 10 raised to negative 3 per degree Celsius. Solving for R2 equal to 50 times 1 plus 3.785 times 10 negative 3 multiplied by T2 100 minus 30. So R2 equal to 63.247 ohms. Pagpasensyahan yun kahit natagariti po madaman ti construction.